Hi everyone, we are here to present our new project, Mocka, a mock server for developers by developers. But first, who are we? I'm Fabrizio Brancati, iOS tech lead at Wise Emotions, the digital factory of Telepass. I'm a Revenderlic author and also an automation lover.
Hi, I'm Firas. I'm a senior iOS engineer at Wise Emotions. I'm a design enthusiast and I'm a refactoring sociopath.
So why we created Mocka? Let's consider these cases. You agreed on a new feature with your backend team, but they still haven't got around to developing it. Do you want to test extreme scenarios and can manage your backend? Your QA team wants to test various cases without using different user accounts. How can we go about these questions? We have three possible routes. The first one is mock the responses by code. The second one is mock the app by using the URL protocol. The third one is using a local server. Let's take the first one, mock responses by code. No one wants to manually add responses directly in the code. It requires a lot of boilerplate code. It's verbose and makes pull requests way too long. Not to mention that it doesn't scale if you need multiple responses based on the same request. So this is a bad solution. The second one is mock the app by using URL protocol. It is more suitable for unit tests, but it doesn't scale if you need multiple responses based on the request. So this is a good solution. The third one is using a local server. It offers flexibility and if done properly has an insignificant impact on the codebase. In addition, it allows to quickly iterate between different scenarios by switching the response file or status code. So this is the best solution, and let's follow that.
There's a lot of applications that can run a local server. Let's see together the top ones and go over their pros and cons. First off, we have Postman, a software usually used to send HTTP requests rather than mocking them. However, Postman is not an open source app and therefore you cannot request any custom features or develop them yourself. Then we have Mokun. Mokun is a great software. However, it's written in Electron and therefore in TypeScript, which is a language we do not usually use. And then we have JSON Server, a Node.js package that allows to create custom routes and send custom responses accordingly. We started using it internally to mock our app, but the lack of the UI interface and the fact that it's written in JavaScript, a worse version of TypeScript, made us want to create our own Swift solution. We call it Mocka. So why Mocka? We usually like to have fun when it comes to names, so we brainstormed different ideas and decided to come up with a name that combined mock data with one of Italy's finest engineering solutions, the Mocka pot. Not to mention that it's one of our favorite beverages that fuels our coding daily. We thought of every detail when it came to the app, even the icon. As you can see, here we see the evolution of the icon from the first idea to the last one, where we decided to make it as Swifty as possible that matches the new style of Big Sur. We didn't stop at the fancy icon design. We worked hand in hand with our designer to get the best user experience out of Mocka. We thought of every design detail that would have made our life easier. Every UI element and functionality had us, the developer, in mind. With Mocka, we wanted to have all the information in one place, properly organized, and have it look hip. So you're probably wondering by now, how is Mocka made?
No, seriously, we created the app in our spare time. the company allowed us to use it for projects other than our main apps. So we wanted to use all the latest frameworks that Apple released in the last years. We used vanilla SwiftUI and Combine. But what about tools? We are a big team, so we wanted to avoid all kinds of conflicts. For that reason, we use Xcode Jam, a tool we are familiar with because we use it daily in all our projects. To format the code, we use the official Apple Swift format package. With that, we were able to use a shared style throughout the project. We added this on the CI level by cloning the official repository, building the module, and running it remotely. If there are any code style to fix, those will be automatically committed to the Mocka repository. Talking about CI, we wanted to use one of the latest features that GitHub offered, the GitHub Actions. The only limitation is that macOS 11 is currently not available, so we can't run tests or automatically create a sign up.
Now let's talk about how we embedded a server inside of our application. To do so, we opted to use Vapor. Vapor is a solid open source server-side framework that allows to run a server instance, intercept requests, and send responses accordingly, among other things. Vapor allowed us to avoid having to write a lot of low-level boilerplate code and having to deal with the bugs that comes along with it. Now let's see how all of this works. When we start the server, we inject an array of custom requests. These requests contain all of the information needed to create the Vapor routes. A request contains the path, the method, and the response desired to have. The response object, in its turn, contains the status code, the content type, the headers, and the response file, if any, is present. Once the server receives this array of requests, it iterates over them, and for each one, creates a custom Vapor route. The route consists of the method and the path. Once the route is called, the body is invoked, and the response is returned.
What are the key features of Mocka? Well, at the app startup, it will ask you to choose for a workspace folder. This can be a local one or preferably a Git repository, in order to be able to share your Mocka collection with colleagues. When you press the OK button, a server configuration JSON file will be created in the Your Shared folder in order to share the server configuration with others. After that, you will be able to use the app. So after choosing the folder, you will be presented to an app with three main sections: the server, the editor, and the console. In the first section, the server one, the app shows a list of requests that the app intercepted. When tapping on an item on that list, we will have the HTTP method, the status code, the response timestamp, the URL on top of the tape view. Then we have all the requests and responses properties: URL, headers, query, and body. On the second item on the sidebar, we will have the editor section. The editor section will show us the file tree that gives us an overview of all of the requests inside the workspace. Here we can navigate folders and check for request informations, edit them, and create new ones. One of the key features of Mocka is that the request JSON can be easily edited with any file editor. But Mocka offers a layer of validation that normal text editors don't. By using edit file, you will be able to directly modify that and share with your colleagues easily. The third section on the sidebar is the console. The console is made by a list of useful logs that you will be able to use to debug what is happening on the embedded server. For example, if you want to know what you are sending to the server and why you are not seeing that on your app, you will be able to know that. You can also copy a log in order to be able to paste it elsewhere.
Some of the key features of the server is its ability to process and return different type of responses other than JSON. Currently, we support HTML, TXT, CSV, among others. We hope to include the support for images, PDFs, and many more soon. Another cool feature about the server is what we call the wildcard component. A wildcard component lives inside of a URL path. That path component is discarded whenever the server receives a request. This is particularly handy when a URL contains a variable, like for instance, the user ID. By substituting that user ID with an asterisk, now any user can query the same URL and receive the same response regardless of his ID. Now let's talk about some of the problems we faced while developing Mocka. A key feature we wanted to include was the possibility to customize the response based on the query parameters. In order to do so, we need to extract these parameters from the request. Vapor uses the decodable protocol to do so. However, it's hard to use that feature not knowing beforehand the data structure we want to decode. We do have a trick up our sleeve to resolve this issue, and we hope to be able to release it in a future version of Mocka. Another problem we ran into was during testing. As you can see from this example, these two assert functions do the same thing. However, one passes, the other doesn't. In the first one, which does not pass, we try to access the routes from inside the application instance inside of the server instance. The second one, we create a computed variable inside of the server instance that accesses the application instance and its routes. And for some weird reason, the second test passes and the first doesn't.
We encountered many challenges on the app side too while developing it. The first one was the pass-through subject. This combined subject broadcasts elements to downstream subscribers. Let's take this use case. We are in the server section and we want to start the server. So, the view model of the console section is not created yet. When we start the server and then we move to the console section, it will be empty. That's because the subscriber is connected to the view after its creation. To work around this limitation, we created the buffered subject. This custom subject holds a buffer of values that will only be sent when the console subscribes to this publisher. By looking at the code, we can see that we declared the buffer and its size. We can also have the clear function that removes all the elements inside the buffer. This is useful for the trash icon that we added into the app. Another problem that we faced was the documentation in general, or lack of therefore. Specifically, when it came to navigation view, the navigation view has an undocumented feature that allowed us to create our 3 columns. Usually, the navigation view is used with 2 elements inside of them, one for the list and one for the detail. By adding the third view inside that, we were able to have one sidebar, one list, and one detail view. As you may know, a lot of things are currently undocumented on the SwiftUI documentation, so we will look forward for this year WWDC. By looking at the code, we can see that by defining 3 views inside the navigation view, they will be correctly rendered. We can also notice that we use the environment to pass around the app the currently selected section, and also the network exchanges publisher. That is one of the previously declared buffered subject. One of the funny things is that we created our own colors and we named them with the coffee names like Doppio. Another big issue that we had was with the text field. The server detail has a view that shows all the called API informations. We created a custom list for the headers and query sections to show all those informations. At the first try, we created a text field for every single value, one for the key and one for the value. We have done that to be able to use this component on both read and write mode. So for when we show the API info and when we create the API. What we noticed was that when we tap on API call, there was a delay of 5 seconds before showing the details. By investigating, we discovered that drawing a list of text fields is expensive for SwiftUI. So we started with a 5-second delay while tapping on an item on the list. So to resolve that, we created 2 different views, one for the read mode and one for the write mode. The main differences between these modes was the usage of a text instead of a text field. So with just that change, we went from 5 seconds delay to just 0.8 seconds delay. But we wanted to go one step further. So we tried to use a view modifier called drawing group. By using drawing group on the list level in read mode, we have been able to go from the 0.8 seconds to 0.3 seconds. Drawing group uses method to render the view, but it cannot be used if there are elements with interactions, like a text field for example, inside the view hierarchy. Now I will give the word to Firas that will show you a demo of the app.
So let's get started with our demo. Here we have our application that is connected to our Mocka server. In fact, if we pull to refresh now, we're gonna get an error because our server is not turned on. As we said, Mocka will welcome us with a sheet that prompts us to insert our workspace folder and our server configuration. These values are the default ones provided by Vapor. Let's go ahead and select our folder. We're gonna keep the same address, but modify our port to 3000. I'm gonna click OK. Now we can see the empty state of our server. We can go to our editor and we can see all of the requests that we already configured. We're going to be working today with the get user cards request, and we can go to our console where we can see all of the interactions that are happening with our server. If we start our server, the console will print that it's currently running. In fact, if we pull to refresh, we can see the interaction that is happening between our application and our server. If we go back to the server section, we can see the request that just occurred. Here we have the date, the method, and the status of that request. If we click on it, we can see even more details. We can see the URL that the application queried and the headers that the application sent. If we go to the response tab, we can see the headers sent by the server, the body that was sent by the server, and the URL to which the server responded. Had we used a wildcard component, here we could have had an asterisk instead of the v2, for example, and our server would have responded to any word that would have came instead of v2. Let's go to the editor and see our request. So if we go to core and get user cards, here we can see our request. The first part contains the information related directly to the request. We have the custom name, the folder it lives inside of, the URL it responds to, the method, the HTTP status, and the content type. Below, we can see the stuff related for the response. As we said, all of this data lives on your disk, so you can easily share it with your colleagues. In fact, here we can see the information of our request file, and here we can see the information of our response. Let's go ahead and close our request.json since we do not need it. As we said, we can modify all of the information from here, but the beauty of Mocka is it works both ways. So let's go back to our server now and modify this response.json from here. Let's change the avatar from 3 to 5 and the plate number to Swift Heroes. Now if we save it, go back to our application and pull to refresh, we can see that the plate number changed, so did the avatar. Here on the server we can see the new request with the new headers, new time, and new response. So this is the beauty of Mocka, allowing you to quickly prototype everything you need to test everything you want. Thank you for your time. Back to you, Fabrizio.
Awesome. We plan to add a lot of features inside of Mocka. For example, we will add custom errors, automatic updates, command line support for Linux and Windows, per API delay, multiple response, Swagger import, automatic mock data generator, and response based on query or body, and a lot of more. This app has been an incredible work of all the iOS team at Wise Emotions. Every member played a part in the project. We want to say thank you to Davide, Gianfilippo, Martin, Michele, Davide, and Gaetano.
We also want to thank our design team, especially Valeria, for helping us with our app design and app icon. Moreover, we decided to open source Mocka for anyone to contribute and use. We still have few SwiftUI bugs we are currently solving, so feel free to open a pull request and help us solve them. You can find the Mocka app on our GitHub repository at this link.
Since it's an open source project released on GitHub, we are prepared to use everything GitHub has to offer. So if you find a bug, please open an issue. Or if you solve that bug, or implement a feature, please open a pull request and we will gladly accept any contribution. You can also see what plans we have for Mocka or GitHub projects. You can even ask for a feature. And least but not last, our CI runs on GitHub Actions. Now that you have seen our awesome app, do you have any question?